Here we will be discussing the differentiation of the natural logarithmic function. Find the derivative of f of x equals the natural log of x squared over 2x plus 3. It's important to recall that if f of x equals the natural log of u, where u is some quantity or expression, the derivative doesn't involve the natural log, doesn't involve an ln. The u goes in the denominator of the derivative, and the derivative of u is the numerator. However, before we apply this rule and differentiate f of x, we can use the properties of logarithms to simplify this function. I'm going to expand f of x using the laws of logarithms. And the laws of logarithms state that if you have the natural log of a fraction, that can be broken apart into the natural log of the numerator minus the natural log of the denominator. Additionally, if you have the natural log of something that's raised to a power, that power can be moved to the front of the ln. So our original problem, f of x equals the natural log of x squared over 2x plus 3, is equivalent to f of x equals 2 times the natural log of x minus the natural log of 2x plus 3. We will now differentiate each of the two terms individually. Again, for each of the two terms, we'll be using the rule that states if f of x is the natural log of some u, the derivative is u prime over u. Let's differentiate. In the first term, there's a constant that's multiplied by the natural log of x. The derivative of the natural log of x is x in the denominator, and the derivative of x, 1, in the numerator, minus the derivative of the natural log of 2x plus 3, well, 2x plus 3 unchanged is the denominator, and the derivative of 2x plus 3, namely 2, is the numerator. Now this is equal to 2 over x minus 2 over 2x plus 3. And these two terms do represent the derivative. This is f prime of x, the derivative of our original problem. I'm going to take this a step further, get a common denominator, and write my derivative as a single fraction. The least common denominator between these two fractions would be x times the quantity of 2x plus 3. So I will rewrite both fractions having that denominator. The first fraction had an original denominator of x. To get to the least common denominator, 2x plus 3, I had to multiply the denominator by 2x plus 3. So I'll multiply the numerator by 2x plus 3 as well. And in the second fraction, the original denominator is 2x plus 3. To reach the least common denominator, I multiplied by x in the denominator. I'll multiply the numerator by x as well. Once the two fractions have the same denominator, I can rewrite the problem as a single fraction with that denominator. In the numerator, I'll distribute 2 times the quantity of 2x plus 3 to get 4x plus 6 minus 2x. And then combining like terms in the numerator will give me my final answer in simplified form. 4x minus 2x is 2x plus 6. I'll factor a 2 out to the front. The derivative is 2 times the quantity of x plus 3 all over x times the quantity of 2x plus 3.